We face different crystalline materials in our daily life. Several ingredients used in, for example, in cooking, in baking, are crystalline products, such as sucrose, sugars, salt, sodium sulfate, sodium chloride, table salt, and also active pharmaceutical ingredients, APIs, and excipients are crystallized as solid products and used in pharmaceutical end products in tablets as shown in this slide. And as we can expect, based on these examples, the purity requirements of the crystalline products are to be met in terms of chemical and physical purity. The forming crystals are pure and the impurities remain in the mother liquor. In case of physical purity of pharmaceutical compounds, the required crystal structure should be obtained to ensure desired dissolution property in our body. And crystalline products with the required crystal properties can be final consumer products or other final products, or they can be raw materials in a process producing other final products. Also, the intermediates used as raw materials should reach the purity specifications in order not to increase impurity levels. Industrial effluents can be treated by precipitation to reduce metal concentration. Freeze concentration is used, for example, in food industry to concentrate the dilute aqueous solutions. So to remove water from solution, ice crystals are formed and separated from this solution. And this kind of examples are, for example, fruit juices and beers. In these cases, volatile aroma substances retain in the solution, mother liquor solution. Thus, the release can be avoided, which makes freeze concentration more appropriate compared to concentration by evaporation of water. Furthermore, freeze concentration consumes 7 times less energy compared to evaporation when same water amount is removed from the solution. In the case of we need to concentrate dilute aqueous solutions. And regarding crystallization in future, needs of isolation of solid compounds in new processing concepts, crystallization will have a key role as one of the most commonly used unit operations, usually integrated into wider separation processes. Currently, we are investigating the separation of diols by melt crystallization obtained from a novel biorefinery process. Certain diols can be polymerized and used as stock material for non-fossil fuel-based plastic products. Another crucial recycling example application is metal recovery from electronic device and battery waste or battery wastes. These are examples of urban mining. So the focus is to use secondary materials as resources. And also regarding future needs, so also, for example, ongoing projects, development projects are on novel plastic recycling processing. And this kind of hybrid processes consist of pyrolysis, distillation, and also crystallization. So these are examples how there are needed to have this hybrid type of processes. So we merge several different kind of unit operations. And in our research group, we are investigating wastewater purification by pressurized freeze crystallization, focusing on effluent of metal refineries. And in this case, the principle is the same as when seawater freezes. So forming ice layer contains less salts than seawater, this liquid phase. And concerning our research work, so we focus on, for example, determination of energy efficiency. In the case we are using, for example, precipitation, so usually we need to have some certain chemicals, antisolvents, and so on. So we are investigating, for example, what is the chemical consumption in this kind of processes. And generally, what is very important is that also if we are using, for example, additional solvents, so how well we can recycle them. So it's also very, very important in industrial scale processes. And also this separation efficiency, it's also very important. And we try to somehow maximize the crystal yield and to meet the requirements of this end product properties. It's also quite often the case that we try to identify the critical impurities and minimize their residue in the final product, so to meet this purity requirements of crystalline products. And beside this theoretical topics, we are working on thermodynamics, so we are interested to see what is the solubility of our main compound in different kind of solutions. So if composition changes, so it's very likely that solubility may also change. And also we are working on how to monitor crystallization processes. So this kind of real-time process monitoring tools we are also using. And concerning process simulation, and the motivation why we use process simulation is that if we need to carry out process design, so this kind of simulation tools can be used. So if you are designing larger scale, industrial scale processes, so these simulation tools can be used. And this slide shows two very basic factors which are affecting in crystallization. And so firstly, there's this nucleation rate, and it shows how this very zero-sized crystals, how they are formed. So this somehow demonstrates nucleation. And then the next step is how these tiny crystals, how they grow. So this is these two kinetic parameters we are mainly interested in. With the aid of these kinetic factors, it's possible to design crystallization processes. And at Aalto University, we have the opportunity to utilize, for example, these process monitoring tools in the crystallization kinetics studies, and also we have very wide collection of different characterization analysis methods. So we can focus on crystal structure, we can focus on crystal shape and crystal sizes. And what is also we use widely in our research is to determine what is the purity of our end product. So it's also a very relevant part of our studies. And on this slide, you can see quite typical, like industrial continuous crystallization process. And so here is this crystallization step. And then it's followed by filtration of crystals from mother liquor. So we need to separate this end product. And then there is a thermal dryer. So to remove the moisture of these crystals to obtain dry crystalline product. And in filtration step, it's possible to increase crystal purity. Usually filtration step, it's equipped, or it's possible to use this filter cake washing, replacing mother liquor remained in the filter cake. So we can actually in filtration step also increase the final purity levels. So how successfully crystallization step is carried out, so it affects both on filtration and also thermal drying. So here you can see this typical type of processes which are used. So thank you for your attention.